Hi, this is Miss Sheridan. I'm going to go through some of the notes with you. Today we're going to be solving logarithmic equations. So yesterday we looked at exponential equations, which exponential equations look like 2 to the x equals 8, say. And we looked at how to solve those and how to convert that to a log. We remember how we've been looking at log equations. So you say this is log, this is your base 2, of 8 equals your x and how to solve that way. So today we're going to be looking at logarithmic equations. So we're going to look at equations that are starting in this form of log base 3 of x equals 1. So this is where we're going to take these equations and solve. So we know that the base is 3 to the power of 1 equals x. So today we're going to be solving equations in this way. We're going to be going from a logarithmic equation and solving for it. Logarithmic equations are those equations that have a variable in the log part of the equation. So we just looked at that. And you can see some examples here. Remember that we're going to solve these by applying the properties of logs, so the things we've been practicing, and then we'll rewrite it as an exponential equation. Remember that the x, the answer that we're solving for here, so this x right here, can only be positive numbers. So just watch out for that when you're solving for some of these. So we're going to go through some examples to look at how to solve for these. We'll start right here. So we know that we can change this into and use the properties of logs that we know to rewrite this as an exponential equation. So we'll start. The base is 3 to the power of 2 is equal to, and this is our answer, is x minus 5. Now, important thing to remember when we're solving these algebra functions is that what you do to one side, you do to the other. So in this case, we're going to simplify both sides. So 3 squared, we can simplify that. 9 equals x minus 5. And then what we do to one side, we do to both sides. To get x by itself, we add 5 to both sides. And we have 14 is equal to x. So we've solved that for our x in the equation. We'll do a couple more examples to get the hang of this. And sometimes there will be more steps that you have to do. This next one is very similar. So we have our base 6 to the negative 1 power is equal to all of this inside, so 2x minus 1. And again, we're going to simplify. In this case, when you take to a negative power, remember you change that to a fraction. So this will be 1 over 6. It's actually 1 over 6 to the 1, and 6 to the 1 is 6, is equal to 2x minus 1. And then now we'll do the same thing. We'll do the same thing to both sides. So we add 1 to both sides. When you add 1 to 1/6, you get 7/6 equals 2x. And now we'll divide both sides by 2. Divide by 2. Divide by 2. And that's the same as multiplying by 1/2. So we'll get x is equal to 7/12. Because that's 7/6 times 1/2. Sweet. We'll look at a couple more examples, and in this case we're going to have to take some more of our properties of logarithms that we know about. So we'll look at this first one. Log base 4 of 100 minus log base 4 of x plus 1 equals 1. So we've done a lot of examples where we take something that has a log base 4, for example, and we spread it out so that we can solve it. In this case, when we have the same base, we can combine this. So we're going to look at, it's still going to be log base 4. And now when we have subtraction, when we have log subtracted, we can convert that, we can say that that's division. So we have log base 4 of 100 divided by this whole thing right here. So divided by x plus 1 is equal to 1. So we're simplifying that. Now we have one base, one exponent, and one answer. So we have base 4 to the first power is equal to this whole thing, 100 divided by x plus 1. Yep. Sweet. So now we simplify. We say 4. 4 to the first is 4. It's equal to 100 divided by x plus 1. Remember, this is all together. X plus 1. Good. So now we want to do the same thing to both sides. You do one side, you do to the other. So we want to get this x out of the denominator. And to do that, we're going to multiply both sides by x plus 1 times x plus 1 and times x plus 1. So we will end up with 4 times the quantity x plus 1 is equal to 100. And again, we can simplify. So we'll take this 4 and multiply it by both. We'll expand this. So it's 4x plus 4 is equal to 100. We'll subtract 4 from both sides. We'll come right up here. Is 4x equals 94. And then again, we do the same thing to both sides, and we divide by 4. So we end up with x equals 94 fourths. And you can simplify that to a decimal if you'd like, but it's good in that form. And this next one we don't have to do as many steps as in here where we had to kind of simplify it down first. We'll just start with our base. We can take what we know of logarithms and say that we can multiply this. So it's 4 times log of base 5 of x equals 8. Good. Now we can first simplify, so do the same thing to both sides. Divide both sides by 4. So we have log base 5 of x equals 8 divided by 4 is 2. And now we can solve this. We can set this up as an exponential function. So base 5 to the second power is equal to x. And when we simplify this, 5 squared is 25. So our last example, we're going to look at some natural logs. If you remember what a natural log is, that's a log base e. So we can rewrite this, if it makes more sense, as log base e of 5 plus log base e of x equals 1. And these are essentially logs with the same base. So we can rewrite this either as log base e or as natural log, and their addition, so just like logs have in the same property that we used in this last equation, we can multiply those. So this becomes natural log of, we multiply 5 times x equals, oh no, we lost it again, equals 1. So if this is also the same as saying log base e of 5x equals 1, then our base is e and our exponent is 1, and we say that's equal to 5x. So e to the first is e, and this is equal to 5x. We'll do the same thing to both sides as before, and divide by 5, and we say that x is equal to e divided by 5, which is a number that you can plug into your calculator to solve for.